Well, thank you very much for inviting me to give a Glaister lecture. Yes, I did give one here 3 years ago about soil erosion and other things. But when asked this time, I thought, well, what's possibly one of the most pressing, or at least a problem that you hear most about at the moment, and that has to be plastic. So why is plastic a problem? Well, the trouble is, plastic is wonderful. That's why it's a problem. It's durable, it's strong. For its strength, it's very lightweight compared to other materials like metal and some building materials. And you can make it into absolutely anything, pretty much. I mean, you look at the collection of household goods here. You've got a CD, plastic bottles, a clock, the works, an iPhone. That's an interesting one. I guess you can all guess what that is, a golf ball. Why do I have it there? Because it's a good example of multiple use of plastic in a single object. Because on the outside you've got this hard ionomer shell, and then inside is the bouncy bit, if you like, that actually translates the energy of the golf club into making the ball move. But there are many objects, the majority, that are made from multiple plastics. So that makes recycling them rather a complex thing. And more than just stuff you play with or have around the house. Buildings, these are some flats down on the river in Reading, and these blue roofs, that's a plastic composite. There'll also be PVC doors and windows in there as well. And, well, last but not least, a jumbo jet. 15% of the weight of a jumbo jet is a composite of carbon fibre and plastic. And they brought out a Dreamliner, which is 50% plastic and carbon fibre. Amazing. The reason why? Well, because it's very light for its strength. So if you can fly one of these rather than one that's made out of metal, you're saving fuel. So that's the reason for it. But it takes a lot of plastic to make one of those. A global plastic production kicked off seriously around 1960. Go back to 1950, about 1.5 million tonnes of plastic produced, rising up through 1960, and then now it's in excess of 400 million tonnes of total plastic materials used across the world. Amazing. And by 2050, well, this is anybody's guess actually, but if you just follow that exponential function, then this would suggest that they'll be manufactured in 1850 around 1,800 million tonnes, 1.8 billion tonnes annually of plastic. Tremendous. Most of the world's plastic is made in China. We make a fair bit of it in Europe and North America. So it really is an interesting conundrum exactly where this is going. What do we do with the plastic? What do we make it from? That's another issue altogether. Plastic, one of the wonderful things about it is that plastic isn't just a single thing. There are lots of different plastic materials. So we've got polypropylene, low density and linear low density polyethylene, fibres, polyacrylates, polyester, polyamides, the whole lot of them basically, PET, plastic bottles, polyurethane, which is a thermo set rather than the thermoplastic. But this whole lot is in excess of 400 million tonnes per year, which is quite something. And plastic is used in different sectors, and according to where it is used, its lifetime varies tremendously. So if you look at the extreme, if you like, plastic that's used in building and construction, so that can be roofs and PVC doors and windows, that kind of thing. So that might stay where it is for 30 or 40 years perhaps. But you look down the other end, you've got packaging, consumer and institutional products. Well, that's, for example, plastics that are used in the medical industry, that kind of thing. Well, these don't have a lifetime in use of more than a year, probably less than a few months. So the biggest problem in terms of plastic waste is packaging, basically, and these other things, including medicals. But packaging and single use of plastic, this really is the problem, the major issue. Now, since 1950, it's reckoned there's been about 8.3 billion tonnes of plastic produced. And okay, that was drawn up in 2015. So you can add another billion or so to that by now. We're in 2019. And of that lot, a couple of billion tonnes is still in use, as it were, but 80% almost has accumulated in landfills, or it's escaped into the natural environment. And only about 9% has gone for recycling, and 12% has been incinerated. And not all of that has been used to recover the heat. So effectively, it's just been set fire to get rid of it. But a lot of material that could be used in some useful way has not been. And the consequence is we are now drowning in plastic. This is a recycling plant in China, mostly bottles there from what I can see. So this chap, you know, it's a great heat basically if you blew this up. He's collecting this to be passed on for recycling. Of course, China has now imposed bans on taking everybody else's plastic rubbish because they're concerned about their own environmental situation. And they will buy plastic waste from other countries, but it's got to be properly sorted, clean. You had stuff going over to China, shipments, there were newspapers, there are all sorts of different kinds of plastic. And they say, well, no, we're not going to take this stuff anymore. So the rest of the world, including the United Kingdom, have got to think of something else to do with their plastic rather than just sending it abroad. Plastic waste, well, okay. The top 15 countries that, if you like, have mismanaged plastic, that's to say, allowed a lot of it to get into the environment and into the landfill. Well, China is at the top, which is no surprise. They make a lot more plastic than anybody else. Indonesia, Philippines, Vietnam, Sri Lanka. But I mean, people tend to turn around to the Far East and say, oh, you know, big bad China, etc. But the reality is we have outsourced so much of our manufacturing to China. We don't make stuff in this country like we used to, and indeed in Europe and to some degree in North America. So it's no big surprise that these countries are, if you like, the biggest polluters. But of course, they and all of us need to manage plastic better so that it doesn't escape into the environment. Now, I don't know if you came across Plasticus. He was a nice boy, wasn't he? He was a whale, and he wasn't a real whale. He was actually a publicity stunt, if you like, by Sky Ocean Rescue. And he was a sculpture made of 1/4 of a ton of plastic waste. And he did a tour of the country. And the significance that 1/4 of a ton of plastic waste has is that is the amount that enters the oceans every second. So every minute, 15 tons goes in, a huge lorry load. So that's what Plasticus is about, saying that's what 1/4 of a ton of plastic waste looks like. And that's going into the oceans every single second. And 80% of ocean plastic, actually, you might think that it's dumped at sea, but no, that's not the case. It actually comes from land-based sources. So about 9 million tons of plastic waste actually comes from near coastal regions. That's to say within about 30 to 50 kilometres of the coastline. About another 500,000 tons comes from further inland. And we see that a lot of this waste from further inland, this is what they call primary microplastics. That's not stuff that is degraded into smaller and smaller particles over time from larger objects. This is stuff that started off as small fibres, microbeads, etc. I can't actually read that on there, but you can see there's a big issue that washing synthetic fibres releases huge amounts of microfibres into the environment that ends up in the ocean. The erosion of paint, for example, that's another one. You might not think about it. Tyre dust, something like 1/3 tons of microplastic entering the oceans every year is from the abrasion of tyres on roads and brake pads, and the erosion of paint on road surfaces, off ships, everywhere else. So this lot adds up to another 1 million tons of microplastics. At sea, well, getting on for a couple of million tons of plastics are indeed discharged. A lot of those are abandoned fishing nets, what they call ghost nets, that simply, well, they float around, animals get caught into them, and they do tremendous damage. And overall, maybe something like 12 million tons of plastic from all these activities ends up in the ocean every year. Now, the curious thing, the question you might ask is, well, where is this plastic? Because when they put these very fine filter trawl nets, probably not more than 1 metre down, they've only found about 1% of all the plastic that was released into the oceans, probably about 150 million tons since 1950. And they can find less than 1% of that. They can't even find more than a couple of percent of the plastic that goes in every year. So where is it? Well, they've assumed here, obviously a lot of it washes up on beaches, we're familiar with that, but the missing plastic here in this slide, they've assumed it's just sunk to the ocean floor. Well, it's a bit more complicated than that, or rather more uncertain. And just continuing this, it's reckoned that there might be more plastic by weight than fish in the sea by 2050. Amazing statistic. So, okay, a huge production. This is only 1,100 million tonnes assumed, not 1,800 by 2050, so assuming that production rates will fall. But also, the whole plastic industry consumes something like 6% of all the oil and natural gas liquids used by humans on Earth. And it's reckoned that to create this amount of plastic, reckoned to be being produced in 1950, will take 20% of the global oil supply. Now, seeing as we've already got issues in maintaining the global oil supply to really run the whole of civilization, transportation mostly, and provide energy, I'm not convinced that that's really going to be possible. So the plastic industry, certainly in terms of petroleum-derived plastics, may actually start to slow down because there isn't the raw material around. Also, plastic's share of the carbon budget is about 1% at the moment. And to make that amount, that would have to rise to 15% because, of course, we have to cut the carbon budget. We have to cut the amount of carbon being released into the atmosphere. So if we were going to produce that amount of plastic, then that would leave only 85% of the carbon budget for all other purposes. Again, it's looking like something that will be very hard to meet as a target. As I said, the missing plastics, only less than 1% of the plastics has actually been found in surface waters. So this is the missing plastics problem. Where's the rest of it? Where's it gone? Okay, well, some of the particles could be very small. That's to say these filtered trawl nets. They just slip through. They don't actually get collected in them. Or they could be below the surface. So they've done some sampling maybe down to 5 meters below, and they've found a hell of a lot of plastic. Interesting. Now, really quite alarmingly and amazingly, microplastics have now been found in the deepest regions of the oceans. So the Mariana Trench, which is the deepest trench on Earth in the ocean, 11 kilometers depth, which you might think would be totally pristine and free because it's away from where humans are doing anything. No, they found plastic bags down there. They found microplastics in huge concentrations, actually. So it seems to be becoming a literal sink for microplastics. Amazing. So this suggests that actually plastics are becoming dispersed throughout the entire marine ecosystem, and by 2050, it'll be everywhere. You won't be able to look for microplastics or plastic in some form without finding it. Plastic particles, microplastics, interact with organisms, so they get eaten by zooplankton, for example. The zooplankton then excretes the plastic particle, and then it sinks. Or you get algae growing on them. And again, that increases the density, so they're sinking down through the ocean system. There's one thought that microplastics may be consumed by organisms. They physically digest them in some cases, and that releases greenhouse gases. Not proven, but it is a strong possibility, and considering the quantities of microplastics and the quantity of marine organisms there are, if that's the case, then that could be a significant greenhouse gas contribution. Huge concentrations of microfibres. Microfibres are something special. They're little tiny spear points that can basically get into tissue or get down into ocean sediments. They found a lot of them in many oceans across the world. But of course, it's very difficult to measure through the entire ocean column. I mean, the oceans are huge. Of course they are. They are oceanic, literally. And you can't measure depths in between the surface and the ocean floor. Trawling at the surface is one thing, and basically going down and digging a bit of stuff out, or going down with one of these the bathoscope devices and a camera, you can get some idea. But what's in between, well, really, nobody entirely knows, because you cannot physically sample all of this. Now, plastic is persistent in the environment, as we know. One of the wonderful things about plastic is it's so durable. Well, if you want your PVC windows to stay in for 20 or 30 years, that's wonderful. But of course, when it gets in the environment, it still degrades only slowly, and that's very bad news. Now, plastic in the oceans, that's a big question, a big concern at the moment. Does it ever fully degrade? Well, probably not. It just breaks down into smaller and smaller particles. What you would really want it to do, in the open environment anyway, is to literally break down into carbon dioxide and water to fully biodegrade, or compost if it were in landfill. But you need a combination of a certain temperature, you need UV light, not much of that down in the ocean depths, nor oxygen. So you're probably getting a breakdown of the plastics into microparticles and even nanoparticles, very small ones. You see statistics, how long does it take a fishing line to degrade? 600 years, 450 for a nappy, 450 for a plastic bottle, etc., etc. And 200 years for an aluminium can as a kind of reference point. Polystyrene cup, 50 years. But really, nobody knows at all. Plastic hasn't been around for 600 years. These are estimated from sort of kinetic measurements. Really, nobody knows whether this stuff will degrade, in what form it will degrade, to what degree. So it's unknown. But what you can be sure about is that plastic hangs around for a long time in the environment. You know, that much is definitely clear. Now, microplastics, okay, I've referred to microplastics. You see a lot of reference to microplastics, certainly in the media. There's no hard definition for what a microplastic is. Other materials, you talk about macro, meso, micro, in chemistry, for example, in porous carbons and things like that. But a working definition is a microplastic particle has a largest dimension less than 5 millimeters, so smallish. Some of them can be very, very small. But the primary microplastics, they're that small when they get into the environment. So that can be microfibres from washing clothing, microbeads, which have largely been banned, certainly in the UK and a lot of other industrialised nations, plastic pellets, so-called nurdles. These are little lentil-sized pellets of different kinds of plastic, and they melt these down and then form them into plastic objects, whether it's a bottle or a window or whatever. Now, the secondary microplastics, they're also 5 millimeters or less in size, but they're formed by the breakdown of larger plastic objects, so water and soda bottles, fishing nets, plastic bags, and so on. And you can really say that they are found everywhere. Is that a sweeping generalization? Well, okay, if I say they found them throughout the oceans, they're sampling them in the air, we're breathing them in as we sit here. They're in rivers, they're in aquifers, deep water aquifers. They've been found in pristine soils in Swiss mountains, in Arctic sea ice, in the bodies of insects, in drinking water. Bottled water contains even more microplastic particles than tap water. In food, honey, beer, sugar, salt, seafood. So really, they do seem to have got into the entire Earth system. And the majority of birds, fish, sea turtles, whales have been found to have plastic items in their stomachs. And in some cases, microplastics have been found in the liver and the brain. Again, all of this science is in its infancy. It's not fully known in the open environment what the health, obviously if you've got an animal that's being tangled up in a fishing net, and that's what's killed it, it's the plastic getting inside their bodies, indeed in human bodies. What it is the plastic likely to do to us? Probably it's not going to do us much good, but the science is not firm yet, because people have only really been looking into this within the last few years. So it's an interesting field, but I suspect there will be an awful lot more information available over the next 10 years and beyond. No. Right, this is a good one. Microplastics in the air. Okay, now there was concern because it was shown that various kinds of seafood, mussels for example, were ingesting, they were eating and taking into their bodies microplastic particles. And it's reckoned, obviously depends on how many mussels you eat in a year, but they worked out that somebody might get 100 or so microplastic particles per year in the UK, an average mussel-eating Briton, basically. However, that might be alarming. But on the other hand, when you work out how much there is in household dust by way of a concentration of microplastic particles, it's 300 or 400 times. And so whatever we do, we stand here, we eat not seafood, we eat chips or whatever, that's going to have microplastic particles raining down on it onto the atmosphere. So the load that we take in just generally from the air, through any food, through anything we do, is much greater than from shellfish. So you might say, well, okay, that's just a supposition, a measurement of what's in the air. So are we really getting microplastics in our bodies? Well, this is an interesting question. However, in a small sample, 8 volunteers across 3 continents, microplastics have been found in human stools. Interesting. And this lady is obviously analysing them there. And not the most glamorous job in science, possibly. But anyway, something like, well, it's a range, but about 20 microplastic particles found in each 10 grams of excreta. And they found 9 different kinds of plastic out of the 10 that were being tested for. Again, this does suggest that it's really getting into the food chain, which is, again, I'm sure there will be a lot more information available. You hear about ocean garbage patches, and it's often portrayed in the media. These are like floating islands of plastic, sometimes said bigger than the size of Texas or something like this. Well, that's not actually what they are. Mostly, although it's true that these are gyres and they're whirlpools of water, which the currents have basically concentrated plastic items, plastic particles into, most of what's there by number of particles is microplastics. So most of the mass is actually, for example, abandoned fishing nets. That gets drawn into these gyres. But the greatest density, and yet that might only be 4 particles per cubic metre. So if you were looking into this from a boat, well, basically, you see the odd floating item, but you certainly wouldn't see the microplastic. So it wouldn't appear as an ocean of plastic. And it's not true that you can see them from space, for example. This is an exaggeration, because they are in this rather dispersed form. But amazing that half of that in the North Pacific garbage patch is actually abandoned fishing gear. So that is really causing a lot of trouble. We know plastic washes up on beaches, so per 100 metres about 500 items, and 3/4 of them are plastic. So you can see drinking water bottles, plastic packets, fag ends, cotton bud sticks. I'm surprised all this single-use problem of plastic knives and forks, etc., because I can't say I ever use them actually, but obviously they are used a lot. Fishing line, all this kind of stuff. Now, okay, right, okay. This is, it looks wonderful in many respects, but the after. The before looks absolutely dreadful because you've got all this plastic that's washed in from the oceans. It's basically strangling this beach. And it says it took, well, nearly 2 years and thousands of volunteers to clean up this beach in India. The payoff, hundreds of thousands of sea turtles hatching this week, which is fantastic. Anything can be clean. But it strikes me it's a bit like painting the Forth Bridge, that continually this plastic is going to wash in from the ocean. So the moment people, well, they have other things to do, whatever, they stop doing that, then the poor sea turtles, I think, are probably not going to be there in such a pristine state. But it does make various points, actually. Okay, now, plastic recycling. Have we jumped over? Yeah, plastic recycling. Okay. Well, this is what we all think it to be. Basically, you collect it, that's important. It's sorted, it's basically strapped up, it's crushed up, it's converted into new pellets, into nurdles, and then these granules are then made into another reusable bag. Well, it sounds simple, but it's not quite as simple as that. And okay, as I said before, one of the greatest plastic manufacturers, also plastic polluters, but plastic handlers, is China. So you've got this chap here, he's been described as a plastic recyclist by some wag, and there he is, he's got, I don't know what that weighs, probably, well, it's probably a lot anyway. He looks like it's quite heavy, doesn't he? And he's obviously taking this off to sell it to a recycling centre. Now, which plastics are recyclable? Well, in principle, they are in some way or another. But the reality is that, okay, polyethylene terephthalate, called PET here, usually just PET. Is it recyclable? Yeah, widely recyclable, a lot of it, more than half of it probably. Same with high-density polyethylene, that is also widely recycled. But the other plastics, they have different properties. They're not quite so readily recycled, not with the conventional collection systems and technology. So as things stand, the majority of all the plastic that's being recycled in ways we understand recycling to mean across the world are PET and high-density polyethylene, not low-density. It has a particular property. So that needs to change if we're really going to deal with this. Okay. Right, and the truth is that little plastic packaging is actually recycled. Plastic packaging is about a third of all the plastic in use. And I'm referring to that especially because, of course, most of this is single use. Half of all the plastic in use is used for single-use applications, and a third is for packaging. Now, if you look at this, basically 14% has been incinerated, ideally for energy recovery, and 40% has gone into landfill, 32% leakage. Well, that's to say it's just got into the environment somehow. It's washed into rivers, it's blown away, nobody knows where it is anyway. And basically, another 14% collected for recycling. I don't know why this isn't a bit brighter here anyway, but we shall persevere. 14% is collected for recycling. About 4% of that process losses, well, it doesn't end up where you want it to at the end. Cascaded recycling, 8%, that's basically downcycling. So, for example, your plastic water bottle doesn't end up being recycled into another plastic water bottle. It ends up as a carpet or a park bench. It's a lower quality material, if you like. And only 2% is closed-loop recycling. That's to say your plastic bottle gets recycled into another plastic bottle, effectively. So it's really quite limited at the moment. And as you see, almost 3/4 of it ends up as waste in some form. So that really does need to be addressed. The linear economy, well, the European Commission, for example, are very keen on the circular economy. The linear economy is the problem we have at the moment. The European Commission is keen on the circular economy, as is the Ellen MacArthur Foundation. And they've produced a lot of documentation, very well worth reading. But the problem, as you know, with the linear economy, you take something you make out of the ground effectively, you make something from it, and at the end, you've got waste. You've got to do something with that. Mostly it just gets chucked away. The circular economy is really based on how nature works. It's a sort of almost like a permaculture approach. There's no waste. Waste actually becomes a resource, like it does in a forest, so it goes round and round. So that's the difference. The circular economy, you design what you do when you make it so that it can actually not be disposed of, but it can be returned into the system. So it's kept within the economy, within the actual mechanism of how the society works. And it's reckoned if we really went for the circular economy, we could cut global CO2 emissions by about 70%. I don't know the veracity of that, but clearly you would be using a lot less energy. Most of that comes from the fossil fuels. So yeah, you probably could save an awful lot. And what we do with plastic is being considered by the EC and also the Ellen MacArthur Foundation as a really critical part of the circular economy. And what we have here, this is the Ellen MacArthur Foundation, a new plastics economy. And the idea really is plastic never becomes waste or pollution. I mean, it's a tall order. 3 actions required to create this circular economy for plastics, so you're keeping it in play. Basically, to try and eliminate all problematic and unnecessary plastic items. Well, that would be packaging, another single use probably. Innovation. So in other words, you design what you make out of plastic in such a way, and the plastic that you decide to make it from, so that the object can be reusable, or it can be recycled at the end, or maybe the plastic can be fully compostable. So basically, it can be broken down into humus, into compost that you could actually feed to plants and grow things. And also largely that you circulate all the plastic items as far as possible, so they don't end up as landfill, they don't end up as waste effectively. Now, this is, without going into all of this lot, so this isn't quite so bright, but basically, among the things considered, you actually price plastic. And one of the reasons plastic is used as it is, it's so cheap. But if you were to take the cost to nature and society, the cleanup, the health aspect, etc., the effect on the environment, on other creatures, then it would become considerably more expensive. So the idea is to do that. As I've said already, designing plastic products so they can be reused for other purposes, or they can really be recycled, so your bottle becomes another bottle, it doesn't end up in some other form. Much better collection rates, sophisticated waste sorting, because this is a problem that packaging, for example, it's often made from half a dozen different kinds of plastic. So what can you do with that? You can't recycle it. You try and melt it down. You find the different kinds of plastic floating on top of each other, like oil on water. You can put emulsifying agents in, but again, it's not something you can do in a very straightforward way. And the idea really is that this would give you high quality secondary material that will be cheaper than freshly made plastic. All good ideas, and it would certainly take a lot of effort to do this. But yeah, the idea is looking at plastic not as a problem, but as an opportunity, a resource. So this was from a firm of analysts, Dalberg Analysis, and they're a firm that deals with these sort of things. Right, so what can we do? Well, allowing that the biggest problem is single-use plastic. It's about 50% of all the plastic that's used on Earth. That is where we can make some changes. The familiar mantra, reduce, reuse, recycle, you get in the context of the circular economy. But there have been a lot of R words, actually. You see them around. So we've got repair, repurpose, replace, refill, regenerate. That's important because you don't want to degenerate things. You don't want to degenerate landscapes and so forth. If you actually had compostable plastic, then you could start to rebuild soil, for example. And, well, really, reimagine, redesign, but refuse. We have, within a democracy, a certain power when we go and vote for particular governments or particular situations or not, but we can actually have a very powerful use of our pocket. Just try not to buy things and then try and exert some sort of force that way. So, obvious things, carry a refillable water bottle with you. So, use a bag for life, a cotton bag, something like that. There are various arguments about how many times you'd have to use a cotton bag before it becomes better than a plastic bag, for example, in terms of carbon emissions. But still, one that we'll use for years can't be bad. Microbeads in cosmetics, toothpaste, face washes, all that kind of stuff, they've been banned in the UK, and we no longer are allowed to import goods from abroad that contain them either. That also is from the Sky Ocean Rescue campaign, who came up with Plasticus, the quarter-ton whale that I showed you early on. Okay, now, refill ready. This is a grassroots campaign started by, well, in hand with Transition Town Reading. We certainly can't claim all the credit for it. There are other people far more involved with that. There's a gentleman here who is involved in that. Where are you, Paul? I can't see you from here. Yeah, there you are. Okay. But among the various groups that are interacting with each other to do various things in Reading, we have Refill Reading. So you have these very fetching plastic, or not plastic, they are made from sustainably resourced bamboo from China. Well, okay, but of course, if rather than throwing away how many hundred plastic coffee cups every year, you take that along with you, then there are outlets, many outlets in Reading, that will fill it up for you with coffee, but they'll charge you 10p less to encourage you to do it. So there's a real cooperative spirit in Reading and other places to do exactly this and reduce plastic going into the environment in the form of disposable cups. Right, drinks bottles. This is amazing. This isn't just for the UK. Across the world, 1 million of these plastic water bottles are bought every minute. 20,000 a second. That's amazing, isn't it? Okay, there's nearly 8 billion of us, so I guess that's kind of possible. Almost 500 billion plastic water bottles sold in 2016, and less than 50% are collected for recycling, and only 7% are turned into new bottles. So, you know, there is a considerable change that could be made there. Another point is refill. Well, it's a national campaign called Refill. And when you see one of these stickers in the window of a place, it means you can take your refillable water bottle along and they'll fill it up for you. So we've got 40 such places cooperating in Reading, 2 of which are in the railway station. And there are some that have the refill and also the refill ready, so you can take along your plastic or your non-plastic refillable cup there too. So there's a lot of good cooperation here. Now, I've said that microbeads have largely been banned, certainly in the UK and many other countries. But are microfibres the new microbeads? Are these the new problem? And it's been shown that if you take a washing load, 6 kilograms of acrylic, that released somewhere over 700,000 microfibres. Let's say these are these nasty little spear points. They're probably 4 microns. A human hair is 70 microns in cross-section. These are 4. These are really small. It's a distribution of sizes, but these are little sharp little things. Polyester, well, a bit better. Only 400, I think there's an extra naught on there, 400 or 500,000 of these fibres released per wash. And interestingly, they found that if you use fabric conditioner, it actually increases the release of fibres. Amazing. And I would have thought that if you bought something new, I've got a nice cheap acrylic jumper upstairs, that if I washed that the first time around, that would be the worst. But no, because it's quite cheap. You basically get the material breaking down whenever you wash it as you wear it. So it actually gets worse and worse during the lifetime. So I shall probably get rid of it and buy a good quality cotton one, actually. That is probably a better thing to do. So yeah, interesting. So these are probably worse than microbeads, and there are a lot of them coming from the washing of synthetic fibres. Now, bioplastics. Okay. The International Union of Pure and Applied Chemistry, IUPAC, who basically sets the definition for what you can call things, chemical names, etc. They don't like the use of bioplastics, although it's commonly used. They prefer us to say bio-based polymers. It's more precise. These are polymers that are made from starch, for example, other materials. And you may have seen these. I am not a plastic cup, okay? This reminds me of Magritte's, The Treachery of Images. This is not a pipe. And the way he explained that was, well, try filling it full of tobacco. You can't. It is the image of a pipe. Well, this can be filled with beer, the same as a plastic, an ordinary plastic cup can. But it's made from polylactic acid, PLA. And it claims it's 100% biodegradable. Sounds good, but all biodegradable means is that something breaks down in the environment. It doesn't say how long that takes. It could be decades. It could be 100 years. If it was in landfill, for example, where there's low oxygen concentration and the conditions are not very good for breaking something down. But to say something is compostable, that means it should break down within 6 to 9 months. But that is in an industrial composter. If you were to stick that in your garden compost heap, it would stay there for years, it wouldn't break down. But the industrial composters, they run at higher temperatures, and they can break these materials down. Okay, fair enough. So less plastic waste. But on the other hand, what about other aspects? Well, it's reckoned you could get about 2.5 tons of PLA per hectare. Well, okay, let's say there's 400 million tons of plastic in use at the moment. What if we were to try and substitute all that petroleum-derived plastic by this sort of stuff? If we could, just for fun, let's think about it. Well, it would take about 160 million hectares of land, which is about 11% of the entire arable land on Earth. And if you were to make all the plastic reckoned to be produced in 2050 from bio-based polymers, it would take about half the arable land. So you've got a similar problem like first-generation biofuels. You have only a certain amount of land to grow stuff on, only a certain amount of arable land. So do you want to grow crops? Do you want to grow crops to get starch from to feed people? Do you want to turn it into plastic, or do you want to grow the corn that you get the starch from to make bioethanol? We are on this finite planet, so there are limits to really what we can do. So just trying to substitute one technology for another, it doesn't necessarily stack up against the scale test. Very often it doesn't. This is good news, and this is Budgeons in Belsize Park, and they're the first plastic-free supermarket zones have opened there. You can see mostly fruit and veg, not wrapped up in plastic. It's loose, great stuff, and more than almost 2,000 product lines have been converted over 10 weeks before that article. They've had to invent a new wax packaging for their range of 300 different cheeses, etc., etc. And the owner of the store basically is saying, well, okay, it's pressure. If a big outfit like Tesco's says to Coca-Cola or one of the others, well, we're not going to buy your stuff if it comes in plastic. And change will come very quickly. But yeah, again, it is that kind of purchasing pressure that could make change happen. Now, the counter-argument is, well, actually, plastic packaging leads to less food waste, surely. So, for example, I mean, I don't disbelieve this at all, but you can have bananas. They can last for more than a month in plastic bags. All these others, 2, 3, 4 weeks, etc. But of course, the need for plastic is due to the fact that we have this industrialized food system. We need to keep these things protected because they're moving around nations around the entire world throughout the year. Now, of course, if we were producing more of our food at the more local level, it wouldn't be necessary to keep it protected by plastic or in any other way. So that really brings me on to the crux of the matter, you might say. We hear a lot, quite rightly, about climate change at the moment, absolutely. But climate change, carbon emissions, the effect of that on the Earth system, the way that forces the system to change in various ways that we're familiar with. But I would go beyond that. I call it the changing climate, which you could also refer to as the world's woes. And if you look at this list here, well, yeah, sure, top of the list, carbon emissions, fossil fuel use, climate change. Huge and rising population, which obviously is imposing further demands on what the Earth can provide. The peaking of resources, water indeed, fuels, phosphorus, metals, uranium, soil and fish stocks are in decline as well. Land degradation to the degree that probably a third of arable land has been abandoned due to erosion over the last 40 years. As the soil begins to degrade, the aquifers don't recharge, you get more runoff and you get more flooding, basically. Loss of biodiversity, it is said by renowned people, we're in the middle of a 6th great mass extinction because as far as it can be determined, the rate of species loss is as great, if not greater, than deduced for any of the previous periods, extinction periods. Pollution. Now, okay, when I was putting that together, I put plastic pollution there in smaller type. Why? Well, because trying to sit plastic pollution among all these other tremendous problems, it really doesn't look like the biggest problem we have to face. It's important and we have to address it, but really we have to address the whole system. What we're seeing, these aren't individual problems, they're basically the cracks in the paper. They're examples, basically signs of systemic failure. So that's it. And really, it's overconsumption. We are consuming finite resources too rapidly and too injudiciously, and at such a rate that we can't cope with the product of our use of them. And what we need to do is to address the whole system, an interconnected global environmental set of resource issues. So it's not just plastic pollution, or it's not just peak oil, or any other single one. It is the whole problem that has to be addressed in a single way. So, for example, ban the straw is a great thing, but of course there is the danger people think, well, I've given up my straw and my plastic cup, but I still have 10 holidays a year flying off to different places. And you know, you can pat yourself on the back, but we need to do a lot more than that, as I say, to address the wider system. Ideas like transition, the transition towns, for example, are really focused, they're grassroots movements, they are doing more at the local level. So you don't need your food wrapped up in plastic for 6 weeks because it doesn't have to come across from the other side of the world. And really, by doing more on the local level, of course you're cutting back greatly on the amount of oil for fuels, but also on many other resources that we use quite extremely at the moment. You know the statistic that for every calorie of food on the plate takes 10 calories of fossil fuels. So that's really enormous as part of this huge mechanical industrialized food system. And I do wonder, I came across this idea of deep adaptation, which scares the hell out of me. But certainly perhaps if we can't solve the overall problem, we can't just sort of close the door on it, We need to accept that the changing climate is going to happen. We are part of it, and adapt to it. And maybe not just adapting like building sea defences, but actually we're adapting within ourselves, really how we view existence, how we view the world, what our goals are, etc., etc. David Holmgren, one of the co-inventors, as it were, of permaculture, which is a design system that can be used to tackle all sorts of things. He gave 4 possible scenarios. The one at the top there, he calls Techno-Fantasy. That's the idea, don't worry about it. Technology will always come to our rescue. Not only will we be able to get more and more energy as much as we want, we'll be able to have technology that basically gets rid of all the carbon emissions. Basically, no problem at all. Now, the other end of the scale, he calls Atlantis. You can see what that means. Basically, crash. It would mean a huge loss of population, the whole structure falling apart. He also refers to green tech stability. So it's quite faintness, I don't know why. But basically, green tech stability allows you to do more or less the same sort of things as you are, using almost as much energy as you are now. But you're doing it with solar panels, you're doing it with biofuels, you're doing it in a sustainable manner. Whether you can actually match the amount of energy we get from the fossil fuels at the moment, from alternatives, I'm sceptical, to put it that way. And the other, the third one that he quotes is Earth stewardship. And he's really looking 500 years into the future, old growth forest. He's not put a numerical time scale. It's how long it takes things to actually happen in the natural world. And he said that rather than a solar panel being a good symbol, if you like, a good icon for what the world and humans might be like at the time of an old growth forest in the future, don't consider a solar panel, but a tree, because most of the solar panels will all be trash by then. They'll be chemical waste, effectively. And it's an interesting point of view. What he's really talking about is a sort of going down in terms of our use of energy and resources, generation by generation, because he reckons that each one will have less available to it than the previous. So then it really does become about designing things better and really having a different set of values. And yeah, I think probably he has a fair point, actually. I don't believe technology is going to solve all our problems for us, and yeah, we probably do need to think quite differently. Now, 1955, the American Life magazine. This was the first time that the phrase throwaway society was used, and they celebrated the dawn of throwaway living. And you see this happy family there. They've got all this stuff, most of it's made out of plastic. Basically, the idea was you didn't need things made out of metal and glass that you've got to wash up and deal with. You just use it once and you chuck it away. And that's exactly what we're doing now. And really, we now know that there is no way where we can throw anything. Basically, it all circulates round and round, and this is where we're sitting now. Yeah, how times have changed. And I came across this the other day. I put it there just for contemplation and discussion. I'm not a particularly religious person, but this guy here, he's an interesting fellow, Gus Speth. He's an attorney by background, but he's been an advisor on environmental topics to the US government, many environmental organisations, and so on. But he says he used to think that the top environmental problems were loss of biodiversity, collapse of ecosystems, and climate change. And he thought that by means of science, over 30 years, we could address those problems. He says, but I was wrong. The top environmental problems are selfishness, greed, and apathy. And to deal with those, we need a spiritual and cultural transformation. And we scientists don't know how to do that. And I don't know whether he's right or not, but I think the constant boom of advertising is encouraging us to buy more and more stuff, use more and more stuff, and we've really got to go in the opposite direction. Otherwise, I don't think there is a solution. And I don't think we can make simple substitutions, change a bit here, change a bit there. I think we've got to change a lot, and particularly, I think we are going to end up with a society that, if it is to be sustainable, Maybe it will take as long as an old growth forest takes to grow. But by that stage, whatever humans are left will be using far less in the way of energy and other resources. I think the good times will have rolled, if that's what you can call them. Okay, that's my piece. Thank you for inviting me, and thank you for listening.